Hello, this is Basvi again. Since the proving trigonometric identities is a very vast chapter, I would do one more video on this. I have few questions written here proving sums. Let's see how to work it out. The first one over here is cos square negative theta plus sin square negative theta is equal to 1. This is what you need to prove. So here it is negative theta inside. So that means you are going to use the even odd identities here. So we know cos negative theta is equal to cos theta, right? And sin negative theta is equal to minus sin theta. So I would write that here. So let's apply this here. Cos square negative theta, I would rewrite this as cos negative theta the whole square. The square I'm taking it out plus sine negative theta the whole square. This is your left hand side, okay? So your answer starts here. So this is my left hand side. So that would now be like, you know that cos theta I have already shown you is cos minus theta is cos theta, right? So I can write this as cos theta the whole square plus sine minus theta is negative sine theta. So that's negative sine theta the whole square. Now when you square it, you can bring that square inside. So what happens? This is cos square theta plus, when you square a negative value, it becomes positive, right? So the negative sine theta, when you square, it becomes positive sine square theta. And we know that cos square theta plus sine square theta equals 1, the Pythagorean identity. So I apply that here. So this is equal to 1. So we have arrived at the right hand side answer. Is it clear? So let's go on to the second question here. So, tan square x times sine square x is equal to tan square x minus sine square x. Here I would like to start from the right hand side because I think that would be more easier and would end up with the left hand side, okay? So here I'm writing the right hand side values first. So that is this, I can make it in terms of sine and cos, okay? So here this tan squared x, I would write it as sine squared x over the cos squared x. Okay, this tan squared x has become sine squared x and over the cos squared x. Here I would put the negative sign and then the sine squared x as it is. Since you don't have a denominator here, I just put 1 down here since this side it is a fraction. Now, how do you solve this? We need to make the denominator same, right? So, for that what I do is, I multiply the denominator and the numerator with cos square x, okay? So that the denominators of both these are same, okay? So that will give me sine square x over cos square x, okay? This is a negative sign, it comes from here, minus sign. And this is sine square x times cos square x. And the denominator is 1 times cos square x is cos square x. Now that the denominators are same, I can just make it as one denominator, right? Cos square x. And the numerators I can just write as it is. So that's sine square x minus sine square x cos square x. Since I find sine square x in both these terms, I just take the sine square x in common out. So inside it would be 1 minus cos square x, right? So from these two terms I just take the sine square x out. So here it would become 1 and here you just have the cos square x divided by cos cos square x. Okay, so that I can just write, you have sine square x here times 1 minus cos square x is again a sine square x, right? The whole thing divided by cos square x. Now 1 sine square x and the cos square x, I would just take it as tan square x. So that becomes tan square x times what you're left with? Sine square x. Okay, this is your LHS. Okay, we started from the right hand side and we landed up in the left hand side. You have proved your LHS is equal to your RHS. Hope you understood this. It's very simple. Just apply step by step. You just see what you need to do. When you're working out from the left hand side, you have an eye on the right hand side and you try to take the left hand side terms to match with that on the right hand side. Or as we did in this problem, you can start with the right hand side and you can end up with the left hand side. One thing we are doing is just trying to match the left and the right side and hence proving it. Okay, so here's your third question. Here it's given secant theta minus tan theta times sine theta equals 1 over secant theta. Again, let me start with my left hand side as usual. The secant x minus tan x times sine x. I'm just going to bring everything in terms of sine and cos. Okay, so this secant x is nothing but 1 over cos x, right? Reciprocal identity. Now here the tan identity is sine, the tan x you can write it as sine x over the cos x times, you have the sine x, I write as it is. Okay, now let me put this in a better way. So I would have 1 over cos x minus sine x times sine x is sine squared x over cos x. Since the denominators are same, I can directly do the calculation. I have one single denominator now. I take the cos x in common and in the numerator it is 1 minus sine squared x. Okay, so we know as per the Pythagorean identities, 1 minus sine squared x is nothing but the cos square x. So the numerator has changed to cos square x and the denominator is again the cos x. Cos square x means, this means it is cos x times cos x, right? Over cos x. So 1 cos x gets cancelled. So you are left with cos x. But this is not enough because in the right hand side you have to show that it is equal to 1 over the secant x. But here we have got only the cos x, so still I need to proceed. And I can represent the cos x as the reciprocal of secant x, right? Yeah, now I got the right hand side answer. I have brought the left hand side equal to the right hand side. So hence it is proved. Let's go on to the next problem now. Secant x times sine x over tan x plus cot x equals sine square x. I would again, because on my right it is sine, I will have to turn everything. Yeah, I could hear you telling we need to turn everything to sine and cos here, right? So the numerator is secant x, that I can make it as 1 over cos x, right? This is 1 over cos x times the sine x. It is already sine x, so I just keep it as it is, sine x. The whole thing divided by, at the bottom it is tan x, which I can make it as sine x over cos x, right? plus cot x. Cot x is the reciprocal of tan, that is, it would be cos x over the sin x. Is that clear here? Now numerator as 1 times sin x is sin x over cos x, and here the denominator, it is, I just multiply sin x times cos x here, and you cross multiply here, right? So here you would have sin squared x plus this side it is cos squared x. Now, so to make it neat, I would write sin x over cos x divided by sin squared x plus cos squared x over sin x cos x. Okay, this would be sin x over cos x divided by, look at the numerator here, it is sin square x plus cos square x, which is 1. That identity I have used, Pythagorean identity, and here this one is sin x times cos x. This could be written as sin x over cos x, and now this division I'm just going to flip by making it into multiplication. When I make it as multiplication, the second part of it should be flipped. Okay, you write it upside down. Yeah, you can cancel the cos x and cos x, so you are left with sin squared x. So that is what we need to solve here. We have to prove here. So we got the right hand side. From the left hand side, you have just come on to the right hand side. So they both are equal now. Hence the problem is proved. So this is as easy as this. Only thing is you should be thorough with the identities, all the identities, and you should be able to apply it in the problems whenever needed. Okay, whichever identity to be used must be identified and applied, and then you arrive at the answers. Hope this video was useful to you guys. Okay, take care. Bye.